with one radical. So the first step to solve the equations with one radical is to isolate the radical in one side. But as we see this radical here, this radical is already in one side, so I don't have any other values. I have just alone the radical is in one side and the other variable is in the other side. So this I can go to the second step, which is to square both sides of the equation. And just let me take this here, okay. And now let me rewrite this here, and I'm going step by step. Let me write square root of 5 minus 4x. Inside here is a 4x, and this is equal with the x. So I'm squaring both sides. If I'm squaring both sides, then we're going to have this equation is gonna look in this way: 5 minus 4x and here is a square is equal with x squared. And now this square here is going to simplify with the index 2, and what I'm going to have just a 5 minus 4x, so radical disappears, and then it's much easier to solve the problem as a polynomial without a radical. So already we see this is going to be a quadratic equation. And in order to solve the quadratic equation, we have to put all variables and constant in one side, and in the other side we have to equate with 0. And the best shortcut to take here is I'm going here, for example, to subtract by 5 everything, this side. And here I'm going to add plus 4x because I want to cancel in this side. I want to cancel this side all the variables to make a 0. Whatever I'm doing here, I'm gonna do in the other side too. So I'm respecting the property of the addition of equality. And when we subtract both sides with minus 5 and add plus 4, this cancels everything. Those cancels, and now I have adjusted this equation. I'm going to add, respectively subtract here, and what I'm going to get, we're going to have the quadratic equation, which is going to look x squared plus 4x minus 5 then is equal with 0. And now if we are looking here, this is a factorable, so I don't have to use, for example, quadratic formula, so I can do very easy. And the factors of 5 is 5 and 1. And I'm looking here, for example, how I can reach this term 4. And here is a plus 5 and minus 1. I can plus 5 minus 1 is 4. So therefore this I can factorize in the form of x plus 5. And the other factors is x minus 1. Everything is equal with 0. So if we want to find the solutions, the process is going to give those solutions. X plus 5, the x is going to be minus 5, equal to minus 5. X is equal with minus 5. and the other solution is going to be x is equal with 1. So the process gives us those solutions mathematically. But to make sure those solutions are valid, we have to check those solutions. So in order to check those solutions, we are going to take those solutions that we got from the mathematical process and plug in the original equation. If the equation holds, then this is a valid value. But if it doesn't hold, it's not a valid solution, and that solution that is not valid we call the extraneous solution. So let's check it here. First, x is equal to minus 5. Whenever it's x, we plug in minus 5. So here is a 5, and here we have a 4, but x is a minus 5. Minus 4 times minus 5 is a plus 20. Plus 20. And in the other side we already have x is equal with minus 5. With minus 5. And 20 plus 5 we already is very clear, is 25. But now is equal with minus 5. But clearly we see square root of 25 is a 5. But in other side is a minus 5. We clearly see this is not equal. The left side of the equation is not equal with the right side. And because of that, this is not true. This is not a solution. So because this is not a solution, then it means this is an extraneous solution. So let's check now. This is not a solution. This is not solution. And let's check the other solution. X is equal with minus 1, with 1. And now everywhere the 1 we are going to plug in the original equation, and it's going to look this way. 5 times minus 4. Minus 4 times 1 is minus 4. So we can write 5 minus 4 is equal, instead of the x in other side, I write just 1. And this is square root of 1. And square root of 1 is equal with 1. Because square root of 1 is 1. And in this side I have 1. So this is a valid solution. The only solution that works is this solution here. X is equal with 1.